Hello, my name is Dr. Bunyan and I am the Head of Physics here at Heybridge High School, and I'd like to take this opportunity to do a short presentation to try and encourage you to come here to study A-level physics. Physics is a fascinating subject. It is about trying to understand the universe from the quantum physics that govern things on the smallest scale, such as modern day electronics, through to physics that dictates how galaxies and the universe behave. During your A-level studies, you will study a range of topics that convey the breadth and excitement of contemporary physics. The course is structured to help you learn about fundamental physical concepts and about physics in everyday and technological settings. The development of practical skills is particularly important, and it forms an integral part of the course. You will be expected to carry out practical work in preparation for your written exam that will specifically test these skills. We have two specialist physics teachers within the department. As myself, this is my 10th year of teaching A-level physics here at Heybridge High School in sixth form. I did my degree in electronics and physics at Edinburgh University before then going on to study a PhD. I've also had over 20 years of research and development in semiconductor devices and micro electrical mechanical systems before starting teaching. There's also Mr. Watkins, who did his degree at the University of Bristol. He also has more than 10 years of teaching experience at A-level physics, all of those being the AQA exam board, which is the exam board that we use here. He also has an interest in building electronic circuits and IT, which can be quite useful in illustrating some of the points that we want students to understand. Science building is right next door to the sixth form building. The photographs that you can see, one shows the main area as you enter science, which has a display showing the faces of a number of famous scientists through the ages. The class you can see is one of two of the physics classrooms that you will spend part of your time in should you choose to do A-level physics here. The final photograph shows, if you look carefully, you can see a number of fine green rings around a central spot. Those green rings are occurring because the electrons that are being fired from one end of the tube to the other behave like waves as they pass through a thin layer of graphite, and therefore they form a diffraction pattern, and that is one of the truly fascinating bits of physics that you will learn about should you choose to study the subject. Currently have 10 hours of time every 2 weeks allocated to A-level physics. That includes 9 one-hour-long lessons and one study period where you can go and do some questions to help consolidate your learning. The lessons themselves are based on a mix of practical work, but also formal presentations of new ideas and concepts that you will be expected to learn about during the years. In addition to that, we have fairly frequent tests to allow both yourselves and ourselves get a feel for the progress that you are making with the subject. We now move on to look at the topics that you would study as part of your A-level physics. The list on the left is the core content, which everybody who is doing the AQA specification does. The one I think I draw your attention to most is the one on particles and radiation. That's where we start to look at physics well beyond what you have done in A-level and start to look at what is inside protons and neutrons. The list on the right hand side is some of the content that you will do in year 13, and the option that we do here is turning points in physics, and there you will look at the discovery of the electrons, so basically the history behind our understanding of what an electron is and how it behaves has evolved. But we also look at wave-particle duality, which underpins an awful lot of modern-day electronics. And one of my favourites is special relativity. I still find it fascinating to think that your mass increases the faster you move, but also if you were to move away in a spaceship at approaching the speed of light, somebody on Earth, their watch will appear to run slow as far as you are concerned, and that's a really interesting bit of physics that we study. to help broaden your understanding of the subject and improve your feel for where it is applied, I would encourage you to read around the subject a little bit in the 2 years of your studies. I, as a member of the Institute of Physics, get the Physics World, and I'm more than happy to bring back copies of that in for you to have a read through. But also I'm more than happy to advise on books that you might enjoy reading that might help you develop a true love for the subject. We also run support sessions after school to help you make the progress that you should be capable of doing. Physics is one of those subjects that can open an awful lot of doors. If you want to look at some of the ideas of careers that you could follow, then I've highlighted a few in the diagram on this page. Clearly, you know, there are teaching and academic type roles that you could go for with further study, but also things like engineering. There are a range of medical jobs that you can go into, developing new techniques for treatment or looking at new techniques to image what is happening inside the human body. There are also non-technical jobs. A number of my friends from university have gone to work in the financial sector, where the analytical skills that physics gives you are seen as really, really important. And clearly there are IT type roles that you could go for as well. So it really does open an awful lot of doors. The key aspects of the course are summarised here. The course itself runs for the 2 years. There are 12 required practicals that you will do in those 2 years, and at the end of that time there are 3 papers that you will sit that will give you your formal qualification. The practicals themselves count towards what we call the practical endorsement, which we have not had anybody fail as yet since the new specification come in, and I would like to keep it that way. The table shows a breakup of how the 3 exams are done. The first paper is on content from year 12 and a little bit on the mechanics from year 13. Paper 2 is the remainder of the core content from year 13 plus some assumed knowledge from year 12, so it's really important that you do actually carry that knowledge through. Paper 3 is on the practical aspects and on the options, which, as I said before, is turning points in physics. And I'd like to leave you with a few of the ideas I think are particularly interesting on the A-level physics course. We've been familiar with the idea for a long time that light is a wave, and if you pass light through 2 narrow slits, you get what we call a diffraction pattern, where instead of just having 2 dots or 2 lines, we get a whole series of little spots on the other side. You might imagine if you threw electrons at 2 small holes, then what you would get is 2 piles of electrons building up, because you know full well if you throw scrumped up bits of newspaper through 2 doors, you get 2 piles of newspaper on the other side. However, it's not what we see. We get a diffraction pattern, so electrons are behaving like waves. In recent years, scientists have gone on to show that you get a similar diffraction for significantly larger particles. One of the pictures here shows the diffraction pattern generated by passing Buchmann's of fullerene, basically carbon-60 balls through 2 narrow slits, and you get a diffraction pattern which I think is quite fascinating. And the other image is the idea of quarks. For years we've just been thinking that protons and neutrons and electrons make up all the matter. Well, it turns out that protons and neutrons are made up of quarks, and that is one of the things that we learn about in one of the first topics that we do in year 12, and I always find that quite fascinating to teach. And that concludes my presentation, and we look forward to seeing you in September should you choose to do A-level physics. Thank you very much for listening, and goodbye.